I've done so many hard casework problems on this channel. Time to do another one.
I got 4 die, and I'm gonna go roll them. And now I need to find the probability that when you take any two numbers of the result and multiply them, you can't get exactly 6. So I got 1, 1, 4, 5. That will work because you can't take any two of those numbers and multiply to get exactly 6.
For starters, there are 6 to the power of 4 ways to choose values for 4 die.
Now it's time to think about the individual numbers and see if they are at risk of having something else that can multiply to 6. So, taking my die, I know that, 1 times 6 equals 6. So, if there's a 1 and a 6, that's not going to work. Also, there's 2 and 3. 2 times 3 equals 6. If 2 and 3 are together, then that's also not going to work out. But 4 and 5, 6 is not a multiple of 4, and 6 is not a multiple of 5. So I can have as many 5s and 4s as I want, and I don't have to worry about some other number that when you multiply by either 5 or 4, you get 6. So I'll call 5 and 4 the safe numbers and the rest the danger numbers. And now it's time to do casework based on the number of danger numbers that there are.
No danger case is the most straightforward. 2 ways to choose from 4 through 5 for each of the 4 places for a total of 2 to the power 4 equals 16. For the one danger case, I still don't have to worry about dangers because it takes 2 danger numbers to multiply to get exactly 6. There are 4 ways to choose a danger number and 4 ways to place the danger number relative to the other non-danger numbers. And as usual, there's 2 to the power of 3 equals 8 ways to pick the rest of the die, for a total of 4 times 4 times 8 equals 128 ways in this case.
So now I'm going to go into the territory where we're going to have 2 or more danger numbers. And this means it's possible to have 2 of the die be something like 1 and 6, and thus have that result not work out. So we need to take all of that into account.
In the 2 danger case, there are 4 choose 2 equals 6 ways to order the dangers and non-dangers without taking specification into account. There are 2 to the power of 2 equals 4 ways to pick the non-dangers from 4 and 5 and having 2 places. And there would have been 16 ways to pick 2 dangers. However, we will have to eliminate cases like 1 and 6 and 2 and 3 because those 2 will multiply to 6. In other words, 1, 6, 6, 1, 2, 3, and 3, 2 are out. So 12 ways to pick 2 dangers. A total of 12 times 4 times 6 equals 288 ways in this case.
I can also do casework on if the dangers are the same or not, but this method is a lot cleaner.
Now, before I get to the 3 danger and 4 danger cases, I want to make an important note. We cannot have 3 or more distinct danger numbers because then we will be guaranteed to have 2 danger numbers that multiply to get to 6. So, with that out of the way, let's start the 3 danger case. There are 4 ways to order the dangers and non-dangers without taking specification into account, and there are 2 ways to pick a non-danger. Now, as for the danger numbers themselves, we're going to have to do some sub-case work. If we are only picking from 1 danger numbers, like as in all of them are the same, we are essentially having 4 options. However,
at this point, I need to also consider not only the numbers that are chosen for the dangers, but also the relative order for them, because throughout my solve process, I consider the order to matter. So basically, 1, then 1, then 6 is going to be different from 6, then 1, then 1.
If we're doing 2 of one danger number and 1 of another, we need to make sure that we don't pick 2 that multiply to get exactly 6. There are 4 options that this can happen. And of those 4 options, we can have 2 ways to pick which number shows up twice. And as for the number that shows up twice, there are 3 ways to order the one that appears twice without respect to the exact values. So in the 2 of one danger, 1 of another danger, there are a total of 24 ways in this subcase, for a grand total of 28 ways to pick dangers, then a grand total of 28 times 4 times 2 equals 224 ways in this subcase. And now I'm going to go for the case where all of the numbers are danger numbers. Again, we're going to have to break them up into subcases. So if all the danger numbers are the same, again, 4 options. If we're doing 3 of one danger and 1 of another, there are 4 ways to pick the danger numbers from themselves, just to make sure that we don't get 2 that multiply to 6. And then we have 2 ways to pick the unique number and 4 ways to order them, for a total of 32 in that case. And as for 2 and 2, again, 4 ways to pick the 2 different numbers from among the danger numbers, and 6 ways to order them because we need to take lookalikes into account, for a total of 24 ways in that subcase. A grand total of 4 plus 32 plus 24 equals 60 ways in that subcase.
Whew, that's a lot of work. When I did this problem, I find putting the information in a table to be very useful in solving. And I also color-coded the information so I can keep track of what I'm referring to when I'm doing the counting. That way I can know what I'm doing. Anyway, when adding up all the possibilities from the casework, I get a grand total of 716, so the probability is going to be 716 over 6 to the power 4. Wait, gotta simplify that because we're putting this in a mathleague.org contest. So the actual answer is going to be 179 over 324.
Hi everybody, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.